everyone, welcome back to my channel Depth First. Let's go over Leetcode problem 347, which is top k frequent elements. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. They have given us a couple of examples and I will review that in a second. Let's look at a couple of important constraints. K will always be between 1 and the number of unique elements in the array. The answer is guaranteed to be unique, so we don't have to worry about multiple valid outputs because there will be only one correct answer for every input. As a follow-up, the algorithm's complexity must be better than O of n log n, where n is the size of the array. Let's start with a basic example. Say we are given this array and k is equal to 2. Here is the count of the numbers. The top two most frequent numbers are 1 and 2. We will now try this array and k is 2 again. So 5 appears 3 times, 8 is 1 time, 9 is 1 time, and 7 is 2 times. The top two frequent numbers are 5 and 7, and we will return that as an answer. The straightforward way to solve this question is to keep track of the number and its count in a count hash map the way I have shown it over here, and then sort the numbers based on its count and return the top k. Sorting takes O of n log n time, but can we do better? One question that comes to mind is that since we care about the top k frequent elements, do we really need to sort everything? How about we just keep track of the top k elements while we are going through the array? That's exactly what a heap helps us do. It is perfect for situations like this where we care about the top k of something. So anytime a problem says, give me the top k, you should definitely consider heap. They are super useful in a lot of these top k problems. Here is the plan. We start by building a count hash map, same as before. But instead of sorting the entire list, we push each number and its count into a min heap. What we'll push is a tuple containing count and the number. But why a min heap? Because this way we keep the least frequent element at the top. If the heap size grows larger than k, which in our case is 2, we just heap pop the top element, which will be the element with the lowest count. By the end, the heap holds exactly the top k most frequent numbers. Alright, so let's walk through how we build our heap using this count hash map. First, we push the tuple 3 and 5. So count first and then the number. Next comes the tuple 1 and 8. Now that we are using a min heap, the element with the smallest count stays at the top, so 8 bubbles up. Then we push the tuple 1 and 9. The heap size has exceeded k, which is 2, so we heap pop the topmost element, which will be 1 and 8. Next, we push 2 and 7. Again, the heap size exceeds k, so we heap pop the topmost element, and this time it's 1 and 9. And that's it. We are left with top k most frequent elements, which is 7 and 5, and that's our answer. So let's go over the code for this now. We begin by using Python's counter, which stores the number and its count in a hash map. We also create an empty list that represents the heap. We iterate over each key and value in the hash map and heap push a tuple containing the value and key into the heap. This is essentially the count and number pair. While the size of the heap is greater than k, we heap pop. Finally, we extract and return just the numbers from the heap. This brings our time complexity down to O of n log k because we are pushing up to n elements into the heap. Each heap push or heap pop operation takes log of k time, since the heap size is capped at k. The space complexity is O of n for the space occupied by the count hash map. Can we do even better in terms of the time complexity? Turns out, yes, we can. There is a clever approach that brings the time complexity all the way down to O of n, and it's based on something called as the bucket sort. Let me make an observation. For any given array of size n, there is no way that the count of an element can be greater than n. That's where bucket sort comes in real handy. It is great when you are grouping values like counts or scores and they fall within a limited range. It is perfect for this use case and it gets us to linear time. So here is the idea. We create a list of n plus 1 buckets where each index I of the bucket represents the count of the number. In other words, let's say the bucket at index 3 will hold all the numbers that appear exactly 3 times in the array. And we do this for all the numbers in the hash map. Count starts from 1, but we include the bucket with index 0 to keep indexing simple, even though it is never used. Once all the buckets are filled, we simply walk through them in the reverse order from the highest count down to the lowest and collect the top k elements along the way. Let's now drop each number into the bucket, matching its count. Before we do that, if you are enjoying the content and the effort that I put into making this video, then please do consider liking and subscribing to my channel. That encourages me to make more videos like this and help others as well. Feedbacks are really appreciated. Please do leave them in the comments section below. The number 5 appears 3 times, goes into bucket 3. Number 8 appears once, goes into bucket 1. Same for number 9, into bucket 1. And number 7 appears twice, into bucket 2. Everything is placed. We just walk through the buckets in the reverse order from the highest count to the lowest and collect numbers until we got our top k most frequent elements. Let's go over the code for this approach. We use counter again to get a hash map of the number and its count. Here we create a list of lists where the index I holds all the numbers that appear exactly I times. We walk through the array in reverse, starting from the highest count, and collect numbers and append them to the result list. If the length of the result list is equal to k, we return it. The time complexity of this approach is O of n, and the space complexity is also O of n. So overall, this is more efficient than the heap-based approach. Thank you so much for taking the time to watch my video. I will see you in my next one. Goodbye.